So here we are given a data that's a 10 million of vectors, and each of the vector is 100 dimensional, and we are also given a point that's a 100 dimensional vector, and we need to find the vectors in the data that are top 10 nearest neighbors that are closer to the point, top 10 nearest neighbors closer to the given point. So we solve this problem using the max heap. The max heap consists of a set of entries. Each of the entry we defined it as a tuple of distance and then index. So for the initial 10 vectors in the data, we do as take each of the vector and in the data and find the distance between the point and then the ith vector in data, and we'll just push that distance and corresponding index into the heap. We'll do the same thing for the first 10 vectors. So that is we are maintaining a max heap of size 10. For the other than the 10 vectors, the rest of the vectors in the data, we'll first calculate the distance between this ith vector in the data and then the point, and we'll check this distance with the whatever the maximum distance so far we have found in the max heap. So if this distance comes out to be greater than the maximum distance in the max heap, then it tells us that there all there will exist definitely at least 10 vectors whose distance from the point that's like less than whatever the distance that we have calculated in this distance that's between the ith vector in the data and the point. So we can ignore this ith data point. So otherwise, if the distance is less than the whatever the maximum distance that you have found in max heap, then we need to remove an entry in the max heap, which is a maximum distance value in the max heap, and insert this whatever the distance we have calculated in as a distance between the ith vector and point, and then corresponding index into the max heap. So following the same procedure for the rest of the all the vectors in the data. So finally we'll end up with max heap consists of a top 10 nearest neighbor vectors and then corresponding indices. So this is how the pseudocode looks like for the first 10 vectors in the data matrix. We just find the distance between the ith vector in the data and the point, and we'll insert the distance and the corresponding index into the max heap. And for the rest of other than the 10 vectors, we'll initially calculate the distance, and if this distance comes out to be less than the maximum distance that was found in the max heap, then only we'll we'll just pop out the maximum distance value in the max heap and insert this corresponding distance corresponding index into the maximum. If this distance is greater than maximum value in the maximum, we'll just straight away ignore that. There already exists 10 nearest points. So finally we'll just take out only the indices and we can return those indices. And let's see the code in action. And these are all the important necessary libraries that we have used, and the time is used for the time taken between the like a piece of code. What is the time taken by the, and heap-q is a library that's used to work with the heaps and the numpy arrays. So this is how we have created 10 million data points. So this specific function creates returns 10 million vectors with the standard normal distribution of 0 mean and then the 1 variance. So we have scaled it to the range of -100 to 100 by just scaling multiplying with 100. Now we have the data, and this is what the top 10 fast algorithm is all about that I have I've given in earlier in the document. So this is all the implementation. So it's actually there is only implementation of min heap in the Python, like a heap q module. So we just take the negative sign of the values stored in the heap and then consider it as a max heap. So that's what we can tweak in that way. And the brute force algorithm is we need to check against our whether our values are correct or not. Whatever the indices top 10 nearest neighbor points that are got correct or not, we just use the brute force. So we just found the distance between each pair of vectors and then sorted it out, taken the first 10 indices. And checking for the 10 vectors, I've got out to be uh, for each of the 10 vectors, the algorithm came out to be correct for each of the time. and each of the values are taken randomly, obviously. So the median of the time it was taken is like a 51 seconds. Thank you.